See what breaks.
All right, hopefully we are now recording. Whoop, hey. All right, so this is Terraform, everything is code. My name is Andy Cowell. I've been involved with LOPSA for, I don't know, 5 or 6 years at this point. The majority of my career has been in what you'd pretty much call system administration, although I've been in a number of roles. I've done full-time development for a while. The majority of my time was actually network administration, been in virtualization, been a cloud engineer, and for the last 4 or so years, I've pretty much been managing a cloud engineering team, DevOps team for the former Scripps Networks and Discovery now. So this talk is going to be specifically about Terraform. Before we get into what Terraform is an infrastructure as code tool. So we're going to spend a few minutes talking about infrastructure as code and how cool it is. Based on my career, you can imagine this is the view I've had most of my days, right? Living in the data center. I built out 3 data centers, I think, for Scripps Networks. Did a lot of this, right? Racking and stacking hardware, provisioning VLANs, you know, big routers, all that sort of stuff, right? And this is kind of how I would try and characterize what I did, right? You tended to have a long lead time. If somebody needed a server, we would have to go get quotes, spec it out, get it ordered, wait for it to actually, you know, many times arrive from China or wherever, get shipped here, get it, once it's here, you know, we've got a facility team that racks it, a networking team that provisions the networking, a storage team that provisions the storage, a sysadmin team that installs the OS on there. The networking team comes back, puts it in the right VLAN. The storage team comes back and provisions the correct amount of storage or the right type of storage, right? So a lot of different teams having to try and coordinate to get this system installed. The configuration was inflexible. You know, if I ordered whatever, 2 CPUs, 128 gigs of RAM, like many times that was just kind of a best guess. Like, I think that'll do. And in the 90 days it takes for that hardware to arrive, you know, I thought more and more about it. And it's like, ooh, well, you know, really I need more CPUs and less RAM, or fewer CPUs and more RAM. That hardware couldn't really go away. Like once we bought it, like we needed to use it. So a lot of times, you know, we would have kind of leftover gear. So before we actually went and got quotes for new hardware, we'd say, well, okay, what about this server? Like maybe this can work. Maybe we'll take some memory out of this server and put in here, and you can have this server. And of course, I mentioned it's a physical manual installation. So, I mean, it worked, right? But it was slower, right? It wasn't quite as flexible or as agile as you might want. In the cloud, and here where cloud's a pretty inclusive term. It could be OpenStack, VMware, various things like that. Often you had no lead time. So that 90-day lead time went away, right? If I want a server in AWS, I've got it in seconds, all right, or minutes, right? One-touch installation, right? I can rig up a button and just punch that button all day long and get every server I want. Flexible configuration, right? I can punch that button, get that server, and if I decide, oh, hey, you know, I look at it for a few minutes and it's pretty clear, like I need, you know, more CPUs and fewer memory, torch it, spin up a new one, right? No reason to keep it around if I'm not using it, right? I can provision another server with the exact same parameters and get an identical server every time I need it. So I can theoretically have a new server every morning that I come into work, right? Fresh and new. And this is kind of key, that physical manual installation is gone. Right now, I've got APIs for everything. So instead of having to open a help desk ticket that went to the vendor management team who would do the order for me, right? Now I've got basically a little web interface I can pass information to, and it will go provision that server for me immediately, or relatively quickly. Any questions? I do appreciate questions. I prefer something a little more conversational. So please, if you have any questions, raise your hand. All right, so we've had automation before, right? We've been able to write scripts, use configuration management to manage these systems. The cloud APIs has sort of extended that to things that were traditionally fairly difficult to automate. We could automate switches 10, 15 years ago. I did. I had a lab of networking switches with a physical console server in front, and I wrote a expect script, a tickle expect script to connect to those consoles over telnet and run the router commands to print out the config and save the config locally, and then send the other, wipe the config, send the other, I mean, it worked. It was pretty janky, but it worked. But with cloud APIs, that stuff is easier, better, more full-featured, more robust. And I think this is another key thing in the cloud, it's increased segmentation between infrastructure segments. So when I built out a data center, I had a couple of core switches, I had a bunch of sort of aggregation switches, I had a bunch of switches out in all the infrastructures, all the racks, all pretty much connected together into one physical infrastructure. And it was not especially difficult for a misconfiguration in one spot of the data center to take the whole data center down, right? So I couldn't allow, even if I had the automation, I couldn't really allow end users to do whatever it is they wanted to do. In the cloud, I can create virtual data centers. I can give everybody in this room their own data center. And now I'm not so concerned about what you do in your data center, right? You say you need access in your data center, man, go for it. Like the only person you're going to hurt is yourself, right? And I'm not really going to care as much, right? You understand you're taking on more responsibility. That means that's what I call a lowered blast radius, right? When something goes wrong, it affects fewer people. I've had entire data centers go down for hours. I've had big storage servers go down and take 1,000 virtual machines down. Man, that stuff's no fun. It's really not. In the cloud, right? You're going to mess up a few hundred VMs. They're all going to be yours. You're going to know everybody you need to communicate with. When I lost 1,000 VMs, that's everybody, right? I don't know who to talk to. It's 50 different teams I got to go talk to and try and get all their servers back up, right? Now, I know what data center is having a problem. I know what team that data center is associated with, and I can easily communicate with them and get things backed up. Since we've got that lowered blast radius, like I said, I'm more comfortable with the end user having access to the infrastructure. Go for it, right? You're not going to mess up the other teams around you. Now that I've got end users access to infrastructure via APIs, via these web interfaces, right? We can talk about infrastructure as code. I can write a script to repeatably create my infrastructure, right? I can take a script and create a data center, create all the networking for it, create DNS, servers, storage, whatever it is I need, right? All from this script. And I can run the script again, and I can get a duplicate of the same thing, the same infrastructure. So that's infrastructure as code, right? I'm able to automatically spin up programmatically very similar systems. So it's really what it boils down to. And really, note, you could argue that we did this 20 years ago, but really it was only the administrators who even had the capabilities to do that. And if that's it, who cares? You still have to open the ticket. You still have to wait for them to get around to it. Like it's just not as good.
So if the end users have the ability to do all this stuff, does that mean that have to be storage admins and networking?
Out of scope for this talk. But I would argue yes, that you can continue to operate in the old model. right? Where you have a storage team that manages storage for you, a server team that manages servers for you, but you greatly benefit by having people on your team who understand those technologies and can be sort of, you know, light subject matter experts. And really that's DevOps, right? If, you know, if you're a development team and you have these operations specialists that do understand how these things work, right? That's your DevOps team, right? You don't have to do it, but to get the full benefit, that's what you want. I mean, you want people who know what they're doing, right? Any other questions? All right. This is the Wikipedia definition of infrastructure as code. It's the process of managing and provisioning computer data centers through machine-readable definition files rather than physical hardware configuration or interactive configuration tools. So in layman's terms here, provisioning computer data centers, right? That's our cloud, loose definition of cloud. That's our cloud data center through machine-readable definition files, right? That's our script. Or if we want to take it kind of one step further, I'm going to build a data structure that represents my cloud, right? And a program that can read that data center in and translate it into cloud APIs. So from here on out, that machine readable definition file, I'm going to call that my data structure that represents my cloud. As opposed to the physical hardware and interactive configuration tools that we've used in the past. There's still place for that, right? But the main thing we're looking at is provisioning our data centers through data structures. That makes sense.
So not only do I have to understand networking, storage, and all that stuff, I don't even get GUIs anymore.
Yes, you can have GUIs. It doesn't preclude you from having GUIs.
I have a question about that.
Yes.
So do you have, or are you going to touch on this? I have trouble weaning people off the GUI, right? And so then they build things and they've got a segmented environment and they build what they think they need. And then that becomes difficult to operationalize because they're like, oh, I couldn't figure out Terraform. I got an AWS console and I clicked all this stuff. And so then the like real ops people have to come in and reverse engineer what they did through the console. Do you have any experience or do you have any thoughts on like how you motivate people to prefer not having to do it?
So, I mean, we've been through similar structures struggles over the years. Honestly, I think you just, ultimately they are the user and it has to be something that's comfortable for them, right? And it may be like a gradual process. Like honestly, some of these people just may need to leave the company, right? And you get new people in who are more open, to procedures like this, right? In the meantime, you just work with them as best you can. You show them, right, that this process, this infrastructure as code process, Terraform, right, is repeatable and dependable and quick, and it's just better. And it's a paradigm shift, right? It is different. It's a different way of operating. It's hard for somebody who's been operating 20 for 30 years and understands one way of working to shift, right? It really is. So, I mean, I have some sympathy, but it's pretty clear like this is better, right? So, small amount of sympathy. Anybody else? Aaron?
So how do you come from nothing where, say I'm building a private setup and I have, I've got some blade chassis sitting over there that are in factory state. I've got some switches. I've got a console server maybe I've set up the console server. How do I go from not having anything under control to the point where I could run something like this? How close can we get to cutting people completely out of that?
It's harder with physical gear, right? Because at some point you've got to connect the server to your console server, right? And it's got to be correct and it's got to be managed, right? So that does make things more difficult. It is absolutely possible. Etsy John Allspaw was the CTO of Etsy, like the little craft seller.
Yeah.
DevOps darling, right? He knows all about DevOps and all this, and he's doing it all in a physical data center, right? So it's absolutely doable. It's more difficult. You know, it's pretty much, you're going to have to standardize your physical infrastructure in order to be able to automate it, right? Anybody else? Move on. So here's an example of a data structure that I could use to provision resources in the cloud, right? If you've got any experience with AWS, even if you don't know Terraform, you can probably read this data structure, right? It's a resource. The type of resource is going to be an AWS instance. Even if you weren't quite sure that that means what you might think it means, you can kind of look down here and it provides an AMI and an instance type, and that's necessary for an EC2 instance in AWS, right? So, you know, so probably an AWS instance named example 1, booted off this AMI, this instance type, right? Pretty straightforward. Based on that, we'll start to talk about a tool, Terraform, which will translate that data structure into a physical or a virtual resource. Right. Terraform is from a company called HashiCorp. They do a lot of, I would say, kind of cloud native, cloud focused tooling. Terraform is their infrastructure as code solution. Terraform is ridiculously easy to install. It's written in Go, so it compiles to a single binary. And you just download the zip file, unzip it. The hardest thing is making sure it's in your path, right? And then you're done. That's it.
So you don't have to run anything.
It is an executable,
Oh, it is.
right? But that's all it is. There's no configuration files. There's no libraries, right? There's no but we'll discuss some other things, but there's no necessary outside dependency that you need.
It's not like install it.
Yeah.
It's just the program.
It's just the program.
Does it behave like an interpreter?
It's really reading a DSL.
I would say yes, right? It's going to read this data structure, interpret it, and then act on it. So yeah, I mean, that is probably correct.
But you can't use it like as a crunch bang interpreter because it expects a collection of files.
Yeah. There's a relatively simple workflow with Terraform. So I've broke it down into 4 steps. The first step, you're going to create that data structure, that template, right? Or you've got an existing template you're going to make changes to. At some point, you've got an updated template that no longer matches reality, right? So at that point, you want to go to number 2. You want to plan your changes. Since I have a template, or since I have this data structure that doesn't match reality, Terraform, you compare the template to reality, and you tell me what you're going to do, right? And I'm going to review that, and I'm going to make sure that Terraform and I are on the same page, right? If Terraform says it's going to delete a server, I need to make sure I'm aware of that and make sure I'm cool with that. And if I didn't expect that, I need to drop back to step 1 and go back to my template and say, okay, what did I do that made Terraform think it needs to delete this server? Once your plans look good, you move on to step 3, right? You confirm it, and then Terraform will implement those changes. It'll take what you've written in the data structure and change reality to match it. So this is the same data structure I showed earlier. And you can see here, it's on my server. It's in a file called ec2-base.tf. So I've got a file there. I have no server in the cloud, so my template does not match reality. So I'm going to move on to step 2. I'm going to plan with Terraform and have Terraform tell me what it's going to do. And you'll see, I mean, you may not notice, but it's crapping out on me, right? Saying, nope, couldn't satisfy plugin requirements, right? So what's going on there? I have to initialize my plugins. So Terraform's got a concept called providers. So it understood that I was trying to provision in AWS and I needed an AWS provider, but it doesn't come out of the box, right? All I got was that single Terraform binary. I didn't get an external provider, right? So before I can actually provision in AWS, I do need to set up one time that AWS provider. And it even tells me what to do. And we can go down here and look at Terraform Providers. That's a command that will show me the providers in my template that I need, right? In this case, I need the AWS provider. You can go to the Terraform website and you can get information about the AWS provider and what things it can provision, how you can configure the credentials for AWS, and various other things about that provider. Now, you can see here, top left, all providers, right? So there's more providers than AWS. And you could argue that a measure of the value of Terraform might be the number of different providers that it has, right? It has a lot of different providers, right? So you can see AWS, but it also has Azure. It's got Bitbucket, PagerDuty, Grafana, Helm, Heroku, CloudStack, DigitalOcean, New Relic. It can provision Terraform, right? So all of these are providers that HashiCorp provides out of the box, right? So these are sort of officially supported providers. There's also the community providers, even more stuff there. Infoblox, Jira, Puppet, Artifactory, Auth0, etc. Right? So a lot of providers. And that's one of the advantages, I think, of Infoblox, right? Google Calendar, right? I don't know, maybe you want to provision a server and you want to put a calendar reminder for your maintenance window, once that server's provisioned, right? You can put both in the sort of the same data structure, and we're going to see some examples of that. So what makes a good Terraform provider? And it must have an API. That may be a little strong, but just for our purposes, it should have an API. The end user, us, we need to be able to set state via that API, right? So I need to create a server with these specifications, right? And I need to be able to query that state. I need to come in tomorrow and check that that server is as I configured it. And if it's not, I will use that API to set the state back to what I want. So that's sort of that four-step model, right? We're going to check reality against our template, and if they don't match, I'm going to correct reality based on my template. When I started writing this up, I tried to think of a wacky API that I could create a provider for. And I thought about the Domino's API, right? Domino's Pizza has an API to place orders for your pizza. The more I thought about it, the more I decided that, well, let's step forward one step. In between me thinking of that and deciding that it's actually going to be my counterexample, that Domino's is actually a bad idea for a Terraform provider. Somebody actually created it, right? So this is not to knock them, but it's really just to kind of discuss like what makes a good provider. Why do you think I would think that Domino's would be a poor example for a Terraform provider?
30 minutes later, your state changes.
Yeah. I want my state to change in ways outside of my control. I'm going to place the order, and my order status is going to be order received, right? And eventually it's going to be whatever, order checked, being cooked, out for delivery, delivered, right? That state's changing in ways that I don't want to control, right? If my pizza is out for delivery, but my little data structure says, place the order. I don't want to run that again and it cancel the delivery and go back to the kitchen and recook, right? So that's sort of a counter argument for a Domino's pizza provider, right? There's a non-functional requirement that the workload shouldn't change state in a desired manner on its own, right? We want to wholly contain state. Now, we're going to see some ways that we can rely on state that we don't necessarily specify, and we can use that, but we don't really want it to go on and change. One of the typical examples, if I spin up an EC2 server and I want to set up DNS for it, I need the IP address. I didn't specify the IP address. It got it through DHCP. It's a random IP address. I need to know that IP address in order to go configure my DNS. If that IP address changes on its own, my DNS is broken until I rerun Terraform. So we don't want those things to happen in what we manage Terraform with.
Spin up something that is just create an artifact and then shut down.
I would not, no, because again, you're expecting that state to change. And I would draw the distinction. I might create the infrastructure that a job like that might run on. The job might run, create the artifact and die, but I want my infrastructure to stay and remain relatively static, even if the things running on it are dynamic. I mean, yes, right. Terraform, I mean, you could write automation around Terraform. So Terraform can destroy, so you can have a creation and a destroy when you're done, and in between, you don't want that state to change. You don't want it to destroy itself. You want Terraform to destroy it. If you want to build automation around something like that, you can certainly do it. But if you're doing like a one and done sort of job, you probably would not use that with Terraform. Any questions? Any other questions? All right, so I'm going to go back. I'm going to do Terraform init. It's going to download my AWS provider. And you see it's downloading version 2.5.0. And it warns me that I have not told it what version to install. It's just installing the latest. The concern with that is tomorrow I might rerun this on another box and I might get version 2.5.1 or version 2.6 or version 3.0, and it may not operate exactly the same. So what I probably want to do, best practice, is to specify what version of AWS provider I expect this to run under so I get repeatable results. Once I got the provider installed, it tells me, go ahead and run Terraform plan, and I'll tell you what it is I'm going to do. Now, here we can see the local file system before and after I run the init statement, the Terraform init. In my local directory, I only have the ec2-base.tf data structure for my server. I run Terraform init, and it creates the .terraform directory. So .terraform becomes a sort of a private directory for plugins and modules and things that Terraform needs that you could pretty much ignore. But you might want to put it in your .gitignore file, right? Hopefully you're using Git to manage this, this data structure so that you can track your versions over time, your version control system, and you may want to exclude that. Here, I've gone back into that file and I've told it for the provider AWS, specifically get this version. So from here on out, every time I create a server from this template, it'll use version 2.5.0 of the AWS provider, and I should get nice repeatable results. All right, so now we will go back to Terraform plan, and it prompts me. It prompts me for something. I don't want to be prompted for anything. I just want to run. But it needs to know what region I want to provision the server in. So I can manually fill that out. We'll fix that later. And you'll see that it says refreshing Terraform state. We're going to have a lot to say about state in a little bit, but we actually don't have any state yet because we haven't created anything yet. We're just running a plan. Here, it is showing us our plan. It's got a sort of a key, anything with a plus is going to be created. Terraform is going to perform the following actions. It's going to create AWS instance, or example 1, as you remember from our data structure. Here you can see, 2 fields in the state, right? The AMI that we told it, and the ID, which is going to be computed. We don't know what that's going to be, but it's going to be in our state, and we'll find out after we provision it. And we'll note here, this plan ran in isolation because I didn't tell it to save that plan anywhere. In theory, I could run plan, it could tell me what it's going to do, and I could apply my data structure later, and the plan may be different because things might have changed, right? If I want to make sure that the plan I'm looking at when I plan is exactly what Terraform runs, I need to save it with -out. Save that plan somewhere else, and then when I tell it to apply, it needs to apply exactly that plan that I've reviewed. Here I've gone back into the data structure, added the region, so it won't get prompted again going forward. Now I run the plan again. This time, I'm saving my plan to /temp/foo. I'm reviewing the plan, making sure I understand what it's going to do. At the end, it tells me that plan was saved, and here's how you apply that plan. Terraform apply plan. We go and apply that plan that we've reviewed. And you see it's creating. And just like life, you can have a great plan, but it doesn't always work out. In this case, it throws up an example and says, whatever, the account that I created this in didn't have a default VPC, so it didn't know what subnet to put it in, so I have to add more information, whatever. It's just pointing out the plan, just because you got a good plan, doesn't mean it's going to work. You still need to watch your execution, right? You need to pay attention to what it actually does, because Terraform does not automatically roll back in the face of errors. In AWS, I spend most of my time in AWS, and we've got a tool called CloudFormation, which is an infrastructure as code tool from AWS. Targeting AWS resources, one of the key differences between it and Terraform is it rolls back, right? If I launch something and it fails, it tries to go back to the previously known good state, and Terraform doesn't. After we run the apply statement, you see I now have this file, terraform.tfstate. This is pretty important for Terraform. If I've got a data structure and it says create an EC2 instance, I've got a server out in the cloud, how do I know that that server is associated with this data structure, right? Well, that's in the TF state file. That's the association, right? If I want to know what I've created from this data structure, I need that TF state file. And if we poke inside it, we can see, well, in this case, our execution failed. So our state file is kind of sparse, but you can see the structure. There's no resources built yet, but it has started to build out that state file. If I go back, I add the necessary subnet ID. I do my plan is good. I do my apply. My apply actually executes correctly. Tells me down here, apply complete, resources 1 added, nothing changed, nothing destroyed. Now I look at my state file, and I can see in my data structure, the thing I called AWS instance.example1 is this server out in the cloud, right? This ARN is sort of the serial number in AWS. You can get other information like your DNS. And that is how I associate reality with my data structure, that TF state file. Any questions?
So is there anything you could have found during the plan stage to warn you that you're missing VPC before running it, or is that something that's only going to come up?
I want to say that it's only something you'll find during execution, right? Because I've told it to create a server, and it does not go and actually try to create the server, right? So there's always going to be the chance that there's just runtime error inside AWS, right? That happens. I don't think it goes and checks, like, I don't think it understands, the provider I don't think understands like every dependency of every resource, right? That's really handled in AWS API. Similar to CloudFormation, I simply lay out the data and pass it off, and then the API will reject it if there's a problem. So I want to say no, it doesn't do that.
Some resources do have validation. Instance is special because if your data sounds particularly old, you can launch instances without a subnet.
Well, right. I mean, that's a situation where that wasn't necessarily wrong, but my configuration in my account didn't match the default options, right? If I have a default VPC, if I have a default data center, it will just build the server in the data center without me specifying it. I don't have a default data center, so it didn't know where to build it. It tells me, hey, you need to provide more information. But that's the API doing it. It's not Terraform. Anybody else? Here I can go into the AWS console and see the server that I created. Right. You can see here's the AMI I created, or not the AMI I created, but the AMI I used to create it, and it's an instance type of T2 micro. If I run Terraform plan again, it tells me, oh, no changes. It's all good, right? Reality matches the data structure, right? I've used the TF state file. I've consulted the server. I've checked all the state of the server. I've compared it to the data structure. Nothing's changed. We're golden. I don't need to do anything. If I go back to the AWS console and I change the instance type, so now the server is much larger. And this sort of thing happens all the time in my experience, right? Somebody doesn't realize that I'm trying to manage this through infrastructure as code, and they go manually change something on the server. In this case, they decided they needed a much larger server. Right. I go back and I run Terraform plan again. It recognizes, hey, reality no longer matches the data structure, right? We need to change T2 2x large back to T2 micro. It's going to update that in place. So it's the same thing as me going through the console and pulling down the little menu and changing the instance type. It's just going to change the instance type back. I run apply. It makes that change. You can see here, apply complete, resources, 1 changed. I go back to the console. I can see, all right, I'm back to T2 micro. No problem, right? Now, this is kind of deceptive. If I go back.
Can I ask you a question about the
Yeah.
previous, sorry.
Sure.
So this is of particular interest to me. Sometimes the plan will say, oh, I'm going to destroy this and recreate
Yep.
it, right? And then you're like, oh, something big's about to happen.
So
but there are some resource types where it says, I'm just going to change this.
I am about to go into that.
That's awesome.
Yes.
Thank you very
Right.
much.
So in this case, we were able to update in place, right? Here, I've gone back to the console. I've done what looks to be the exact same thing, right? I have changed the instance type. Before, I changed from a T2 micro to a T2 2x large. That T2 means I'm sort of in the same family of processors. It's just got more CPUs, more memory, but the same physical architecture. When I go to M5, I've changed my family type, right? So it's no longer the same underlying, the same architecture, the same physical architecture. Now, when I run plan, it's not going to change it in place. It's going to destroy it and replace it, right? Even though, to me, it kind of feels like I did the same thing, right? I just changed the instance type. Well, you can see here, the default for EBS optimized is different between those two instance types. And Terraform says, I'm sorry, the AWS provider says, if you change that, that's not something I can update in place. I have to destroy it and recreate it. So this is why you really have to pay attention to your plan. It's deterministic, but there's a lot of options, and I don't know them all. So, you know, just you run your plan and try and pay attention to what it's doing.
I guess my question is around, like, I think I'm paying attention, but then I still bite myself. Like, do you have any tips for avoiding biting myself? Should I just not keep body parts away from my mouth?
I mean, it's just like this would have caught me. Like, I mean, I don't know off the top of my head. Like I took my AWS certification 2 years ago, right? I don't remember which ones are EBS optimized and which aren't, right? And I wouldn't have known that would have been the feature that would have deleted the server, right? This is why we have dev environments. The good thing about infrastructure as code is I can create a dev environment that totally matches production by building both off the same data structure. And I can test these changes. I can not only plan, I can plan against my dev environment, and I can see what's going to happen. And then once I'm confident those changes are good, I can take that new data structure and apply it against production and get nice deterministic, fingers crossed, results. Yes.
So in this case, is this the human that wrote the provider, their bias, or is this truly technical limitation?
I'm not sure. I poked around a little bit. I got the impression that I could do this through the console and it wouldn't rebuild it. I don't want to state authoritatively. So I think this is just something in the AWS provider.
Okay. I believe in a lot of cases, especially AWS providers, some of the things default based on an instance type, and you can override them and potentially prevent a destroy and recreate. But there is a reason that EBS optimized is also. I don't believe EBS optimized is actually. I've got that backwards. There are some instance types that can be EBS optimized and some that can't. So if you have it on, like we do here, and you're trying to get a tech that doesn't support it, there's no option but to rebuild. But going the other way, you're fine.
All good? In this case, I go ahead, apply my plan, I destroy my old server, I create my new server, and you can see I get a new ID. I didn't really draw attention to the old one, but 2FBD is my new one. 620A was my old one. Here, 620A has been deleted. You see it's still M5 large, like I said it. And then 2FBD has been recreated, T2 micro. That's important. You know, that's not necessarily bad, right? It depends on your workload, right? If I've got, 2 years of financial data on that server, I probably don't want it deleted, right? But if all my data is in a database and there's nothing I care about on the server, man, I'll delete it all day long and get a new server. So it's not necessarily bad or good. You have to understand your workload and what's good or bad for your workload.
Is the AMI ID what specifies the OS that's going to?
Yes. Yeah. And you can see the AMI that I specified is an Ubuntu 1804 server. Make sense? All right. So I've got my laptop. I'm managing all my infrastructure for my laptop. I've got my TF state file on my laptop. What happens when you go to your laptop and you've got the exact same data structure and you run a plan? You don't have that state. Your Terraform says, well, totally new world out there. If you're expecting to work on the same server as me, we have to share that state file. All right, so it can't exist. We can't all work around one laptop. And I actually looked for public domain images of people around a laptop, and I had this in here and went through it a few times before I realized it's Barack Obama.
For real.
Yeah. So yeah, we don't want to all work around the same laptop. We want a way to share that TF state file. And that's what Terraform calls a backend. The backends I have experience with are S3 and Terraform Enterprise. S3 takes that TF state file and drops it in an S3 bucket. And you would have, a state file in there for everything that you manage. And then Terraform Enterprise is the software that you pay HashiCorp a lot of money for that we've had at Discovery. More about that in a minute. But that's going to be how we could all manage the same infrastructure by having that TF state file in S3 using something like this, right? Here's the bucket we're going to put it in. This is the state file right here, right? So we'll probably have multiple state files in our state file bucket. Yeah, that's about it. Any questions about that? I know I presented this at CodeStock and there were questions about locking. For me, I tend to use like S3 for myself and then Terraform Enterprise for collaborating. So I never really had to worry about locking. But I'm going to show an example. S3 has the option to use DynamoDB for locking. Any questions about that?
Do you have any thoughts or experience you can share about how you see, or do you see, the use of different keys as a way to manage the segments that you were talking earlier to limit blast radius? Like, I have this state in this file and controls these assets. This other thing is my other virtual data center, right? Like, how do you sort of organize and scope those things?
The way we have done that is by account.
Okay.
Right. So accounts don't cost anything.
Sure.
Right. So we give your team an account or multiple accounts, and you know that's the blast radius right there.
Is within a single account.
Right.
Okay.
Now,
So then is Terraform Enterprise aware of accounts?
no.
Okay.
So Terraform Enterprise, let me just preface this by this is theoretical because you don't want Terraform Enterprise.
Okay.
Terraform Enterprise has its own access controls and its own users, right? So you may create AD groups that have access to these workspaces and you manage it that way. If you wanted to control like a Terraform blast radius inside a single account, it would probably be your IAM role only allowing you to write to particular keys in S3, right? So you wouldn't be able to touch other people's state.
Sure. Okay. Sure.
So back to that list.
Yeah.
So I admit I'm not familiar with a lot of those, but
It's okay, I'm not either.
like get version control with systems like GitHub or GitLab or Bitbucket or anything like that. Why would you use something like that?
I have a community answer for that question. If you don't mind.
Go for it.
Someone is not going to check it out, and you're going to forget to commit your last state, so you're going to get state inconsistencies.
So, right, but I mean, I would make the argument that you push out your commit and some system goes through and deploys it, not you from your computer doing it.
Okay.
And so it doesn't matter what state everybody has, it's what state the version control system.
So I have seen, I mean, the regular TF state file that was on my laptop, that could be in Git, right?
Yeah.
But you really do need, you know, an automated system and only that automated system managing that because somebody will forget to check out, you know, and fetch the latest state and it's not going to handle locking. So like that's, if you think about Git, it would be very easy for both of us to have the execs. We both fetch, looks good. We make conflicting changes. We both apply and we're in conflict. So that's probably the argument against it.
Okay, and so there's something listening for these, right? I have these commands. You have a Terraform server. I can put these on my
No,
I just
no.
do it from wherever.
it's, you have a Terraform client.
and just
That's
does
it.
things.
You have a Terraform client. I have a Terraform client.
It
We're
gets-
good.
It gets APIs for these providers, right?
Yes.
So there's no way for me to say to limit this,
Limited how?
to say only this system can make these hit all.
Well, you would handle that in the same, I mean, Terraform is acting on your behalf. So whatever credentials you've got access to, Terraform can do, right? So you would limit a particular person Terraform access the same way you would limit their normal access. They can only do what their AWS credentials, their Artifactory credentials, their Auth0 credentials will allow them to do. Terraform does not enable any access. Terraform Enterprise does, but that's a different argument.
You have a service account that's on the server that then your automation from GitLab or GitHub or whatever goes through.
Exactly. So, and at Discovery, we ran this through Jenkins. And that was sort of the advantage we saw from Terraform Enterprise is Terraform Enterprise will run it for you. And you get a nice history of everything that you've done. And like it seemed better than running it through Jenkins. Right? We're in the process of tearing all that out and going back to Jenkins. And we'll talk about why in a little bit. But it's pretty much, you know, money. All right. Continue on. Here I've configured my S3 remote like we saw. I can destroy my infrastructure. And this is a wonderful thing to be able to do because I can build out my data structure how I think it needs to be. I can apply it, I can test it, doesn't work, delete it all, make changes to my data structure, repeat, repeat, repeat until everything looks really nice. It makes life so much easier. That's right, yeah. And here you can see I'm destroying that 2FBD server. All right. This is a pretty cool feature for Terraform. That state file, remember I said associates the real server with the information in the data structure, right? Import allows me to write the state file and say, hey, I don't have to create this server, just put in the state file that that server is this thing in the data structure. And it populates the state file. And from that point on, I can manage this manually created resource via Terraform. Right. So here I've said, hey, I don't have any servers out in the real world. I deleted it, right? So now I can say, hey, import the thing that's referenced in the data structure is AWS instance example 1, right? That's really going to be this pre-existing server out here, 8E45. And you see here, it imports it, refreshes the state, it writes it down in the state file or in the S3 state file, and we're done. I run plan, no changes. Infrastructure is up to date. We're good. So a lot of times, if you're coming into infrastructure as code, and you've got a lot of things that have been created outside infrastructure as code, you don't necessarily want to go recreate them. Well, you don't have to, right? You write out your data structure, you import those resources until Terraform plan tells you infrastructure is up to date, and then you know, well, it's a pretty good chance my data structure matches reality and I can continue to manage things as infrastructure as code now, even though I didn't create it.
Is there any system that would ask the providers and then will create these instructions?
Not that I'm aware of. And the reason why is, you know, there's a lot of options for these resources. And, you know, it's tough to know if it's a if it's a non-default option, it's kind of obvious. If it's a default option, do you write it in there or not? Did you care about that? I don't know. All right, so it's certainly within the realm of possibility, but it's not something I'd want to rely on. I probably would say, hey, you know, load up my data structure with all these resources and I'll go in and fix it up how I want it.
Right, but if I had at least that, then I could have a starting point. Because, you know, if we're talking about infrastructure that's been built over the last 5 or 10 years, right? I'm going through, okay, well, now I'm going to have to manually try and figure all this stuff out. If I could pull down 80% of it.
I'm skeptical. I'm skeptical that it would be easier. It's certainly possible. Sorry, give me a second here. There. Yeah, broke my clicker. I'm skeptical that it would be easier to go that direction, right? Because if it's really complex, then you're going to have a hugely complex data structure, right? So I don't know. What I think is easier if we think about two ends of the spectrum, right? If I automatically generate it, then I get every option. The better thing might be just don't put any options in there. Just get the resources in there, right? And then do your plan. It all looks good. Okay. I mean, I know there's a lot of options I still need to set, but at least I've got everything in there, right? And then you can start to add the configuration that's important to you. I mean, you could, yeah, I mean, that's probably what I would do. I haven't had to do that, but just thinking about it, that makes more sense to me. So the data structure that I wrote is written in the HashiCorp configuration language. You'll see it's literally, well, it's pretty much JSON, right? It's easy to write JSON. In CloudFormation, which I'm more used to, I had to write all my templates in JSON for years. It's not a lot of fun. HCL's better than JSON. Mm-hmm. So you're going to see a lot of references, and this is an important thing, right? So remember my example when I had an EC2 server and a DNS entry. Like the DNS entry needed to query something about that EC2 server. Well, this is the sort of thing. AWS instance dot example1 dot IP address, right? So I can have a little macro to refer to state about another resource. And here's a couple of examples. In this, here I'm creating my EC2 instance, and I need a security group ID, which I have created in the same file up above, right? So I can reference my type, AWS security group, name, DB access, state entry, ID, right? So I can get kind of the ID for it. And here's my DNS example, right? So AWS Route 53 record, www.example.com, references, example1's public IP address. So I can start to stitch these things together. And here you can see, like, this would be a problem if I ran this once a day, and then 3 hours after I ran, the IP address changed. It'd be broke for 21 hours until it ran again, right? So we don't want that state to change. I can have variables. So I could theoretically have the data structure I told you about and ran once in dev and once in prod, and my dev and prod environments match. Here you can see I've got a DNS name, www.dev.example.com, www.prod.example.com, and I can pass that variable in at the command line. And I think in this case, you're going to want you would want two different state files. I don't think you can use variables in state files, so you might need to play games with the state files. Data sources are interesting. Data sources are provided by the provider. And a pattern you'll see a lot in, say, AWS is that in the examples we've seen so far, I gave it an explicit AMI I wanted to create. Ubuntu 18.04, right? But that is a static image, and new AMIs are constantly coming out that contain patches, right? So I don't necessarily want to explicitly tell it what AMI to use. I want to give it like a search and say, hey, go give me the latest Ubuntu 18.04. A data source, in this case, AWS AMI, is sort of like a Terraform way to get access to dynamic data outside the system. So I can use AWS AMI, provide my filters like I would an AWS API call, and then reference that information below. And I can dynamically get, for good or bad, the latest AMI. All right. Any questions so far? Okay, let's hop over to the command line right quick. If anybody remembers the hotkey to make my text bigger. Command plus, there we go. Thank you.
Well, that was lagging. Yeah, that was weird.
Yes. All righty. So there's a concept of modules. You can see I've created a module here for a Linux server. If I come down in here, so we can look at our vars, right? So these are kind of the inputs that this server can take. And it's what you might expect, right? It can take, you know, an instance type. There's a default value, T2 micro, if you don't pass anything in. But some things like host name and domain name, I'm requiring you to actually pass those in, right? So, you know, here's the SSH key, the subnet to build into. You can imagine this as a website, right? It's going to run on an EC2 instance of this type. I'm going to be able to SSH in with this key. Here's the host name and domain name. The payload is going to be the package that I load onto the server. Here, and this is kind of interesting, here's the actual resources I'm creating. And you'll see that I'm creating resources in 3 different providers, right? Well, I guess I've only got 2 resources there. Let me scroll down just a little bit. All right. So the bottom resource here, this is my EC2 server, right? This is my server. At the top, I've got my DNS. My DNS is not in AWS. It's not in Route 53, right? It's in Cloudflare. My server's built in AWS. My DNS is in Cloudflare. And then I've gone to Status Cake to build a monitoring dashboard, right? Using these references, you know, I can get all the information I need, even though I'm building in different providers. Let me go ahead and get this creation started right quick. All right. You can see here, I don't have my API keys checked into my data structure, right? They're external. I'm passing those in as variables. Actually, I don't need to plan. I just need to apply. All right, so while that runs, we'll talk about what it's doing, right? So I've got my server, I've got my DNS, I've got a dashboard page. I'm using my data structure to find the latest Ubuntu AMI, right? And I have outputs. So inside this module, I've got my variables for input, I've got the things I'm building, and then I've got my outputs, which are things that can be queried about what I create, right? If I go up here and I look at sort of the main file for my repo here, you'll see I'm creating 2 different websites off the same infrastructure, right? I've got www.forcedmarch.com with its payload. I've got www.cathartic scream of love and its repo, right? The nice thing about this is if these are customers of mine, if I'm selling these websites to people and I get a 3rd customer, these are the only things I need to touch, right? I just need to know your domain name and where your payload is, and I can automatically spin up a 3rd server with, you know, DNS in Cloudflare and the dashboard in Status Cake, right? If I want to change the architecture of how I build these websites, I go down into the module and change it in one place. And then I push that out identically across all my customer sites. Make sense? Any questions?
How deep in the OS will it go?
How deep in the OS will it go?
I'm cheap and I want to put both those in the same box.
Well, it's, if you look at how I'm doing this, right? This is not a function of Terraform. It's how I've created the module. So let's get down here, module Linux server, look at main, right? I mean, this is an EC2 server. Here's my user data, right? I am creating a server for each website, and I'm depositing that payload for each website. There's no reason why that couldn't have been a single website. I have an array of sites with payloads, and I just loop through them, dropping them all on the same server. I would argue that gets a little bit more into configuration management, maybe than Terraform, but I can certainly hook configuration management into it through my user data. Right? I can pass that information in to my configuration management. Let my configuration management handle all that. Otherwise, I think I'd be stuck doing one of two things: either either doing that all in my user data, or finding or writing a provider to handle that for me. There's no reason why Terraform couldn't do that for me. I don't know that it does. Yeah.
So infrastructure as code and configuration management. So where is the line to say this isn't configuration management for infrastructure, or is it?
It's somewhere inside Ansible. Well, I mean,
It's
yeah.
not an agent, but it still does a check to see, and then it can automatically fix it. So I mean, is it kind of saying this is a CM configuration management for infrastructure?
I mean, I think you could, I mean, there's similarities, right? There's similarities. I think about configuration management is sort of, I guess, I mean, it's pretty similar to state management. I don't know where I would draw the line. I tend to think of configuration management as being on a server, and with all the server-related things, it may benefit you having a dedicated tool for that. Maybe it makes sense for that to be a Terraform provider. I'm skeptical. I still think there's a place for configuration management to do those sorts of server management things, especially if it's a long-lived server. Yes.
If you don't mind me adding on that. One of the things that Terraform is particularly bad at is enforcing state over time. When you run Terraform, it's done until you run it again. You might be running it on a clock. Also, Terraform's templating engine is not particularly robust. So if you need to do things that are particularly complicated, it's often easier to use Terraform to spin up a configuration management engine. It actually has modules, literally, calls them provisioners, just for doing things like bringing up salt on a machine, so that some other tool can carry the things Terraform is bad at.
So if we check my servers, I've got 8 resources added. If I remember correctly, there's a server, a security group, DNS in Cloudflare, and the status cake monitoring site for both. So let's see here, www.forcedmarch.com. Wrong one. So I'm just making sure that my script is done installing everything. Looks like it should be. Oh, come on. There we go. Unfortunately, no sound. You'll have to trust me that the sound was really awesome.
Okay.
Yeah, somebody's familiar with it. It's on the TV volume, I guess.
Okay, where's the TV? I need to hear this.
cathartic scream of love.
Just a con reference.
Yes. I can't believe all this trouble, and it's whatever. I'm not going to mess with it. I'll do it for you. Con! Might be.
I have to ask, do you actually own these domains or you just screw with the
No, those are my domains. Yes. They're just- And con.org is not up anymore. I think that's a travesty, right? I had to go to archive.org to find the files. Anyway, fun and games. Let's see here. Where's my file? Where's my browser? There we go. All right. So to me, that's the cool thing about Terraform is I can provision everything all at once, right? My monitoring, my notifications, my dashboards, whatever you want, whatever providers out there you have, as long as I've got an API, you can kind of tie it all together with Terraform. All right, Terraform Enterprise, what does it provide? Like I mentioned, it gives you a runner, right? It gives you a single place to run all your Terraform data structures, a single place to go to see how they were executed, what the history of the execution was, a way to handle access controls, all those enterprisey type functions around Terraform, right? Ties in to your source code repository automatically. Whenever you commit to the repo, it automatically runs a plan, so you can go there. It's like a unit test for your code. Like, it's pretty cool, right? So I really liked Terraform Enterprise when I first saw it. I thought we were going to get rid of Jenkins, but we're not. But one of the questions that I run into a lot is Terraform versus CloudFormation. I've presented on CloudFormation before. CloudFormation is AWS's infrastructure as code tool. As such, it has kind of an emphasis on AWS, whereas Terraform is more cloud independent. So the big question people ask me is like, which is better? Nothing's better than anything else. It's a cost-benefit analysis. So we can kind of go through the advantages and disadvantages of Terraform or CloudFormation. Accessing third-party services. Now, you saw all those providers. The advantage is Terraform, right? However, you can do all of that through CloudFormation. It's not a focus of CloudFormation, so what that tends to mean is when you need to do it, you have to go do it yourself, right? That's a disadvantage. However, if you have to do it yourself, it's easier to do in CloudFormation because there's a simple JSON interface that you can pass to a Lambda function that you can write in whatever language you want, and you can manage whatever you want on the back end, and all is well and good. If you have to write a Terraform provider, it's in Go, and you've got to understand like whatever the Go architecture of the binary in order to integrate into it, which isn't nearly as easy. I mean, it's not the hardest thing in the world, but it's not as easy as doing it through CloudFormation. Readability and clarity. I think it's easier with CloudFormation, mostly because CloudFormation is kind of centralized. CloudFormation automatically tags all your resources as being built from CloudFormation if they're inside AWS. Whereas with Terraform, everything I didn't put any tags on. So all that stuff's out there in AWS. And just by looking at that resource, you don't know that it was created from Terraform, which is kind of a disadvantage. I really should have tagged it correctly. I think that most people that I see using Terraform, they tend to use that main TF, vars.tf, outputs.tf, whatever. They create their modules with main.tf, vars.tf, output. Man, you get like 2 or 3 main.tf files floating around. And you're just like, you don't know where you are. You're editing one file, you think you're editing the other. It's not great. So I think the edge is for CloudFormation there. Importing existing resources. We saw that. I love that feature in Terraform. CloudFormation doesn't have anything like that. Advantage Terraform. Monitoring and correcting changes to resources. Terraform. CloudFormation has only recently got the ability to detect drift. For years in CloudFormation, it was kind of risky to do an update, right? Because you didn't really know, you weren't really quite sure what was going to happen. They've got better detection now. They detect when reality drifts away from your data structure, but they still don't remedy it, whereas Terraform will. So error handling, I give the advantage to CloudFormation because CloudFormation does a pretty good job of rolling back to a previously known good state, right? Terraform does not. Cost, this is a big one. Well, if you want to spend money, CloudFormation's got the advantage, right? If you require enterprise support, right? If you want support, the only way to get that is through Terraform Enterprise, and buddy, it's expensive. Like it really is. We at Scripps Networks, we engaged with HashiCorp to get some of their tools and just, like it was just, it's nuts, right? We inherited Terraform Enterprise from Discovery when Discovery bought us. It's nuts. So we are in the process of getting off Terraform Enterprise. Like it's not worth it. And we've gone through this process twice. It doesn't seem worth the money. It's a lot of money and it's not worth it. I do see though, what they're trying to do is they're trying to price it as a SaaS product. Yet we have to install it, we have to monitor it, we have to upgrade it. There's no SaaS nothing about this product, Terraform Enterprise. They are developing a SaaS Terraform, and I assume that's why, so they can get that pricing model. Usability, it's a wash, in my opinion. In the process of sort of evaluating CloudFormation versus Terraform, somebody I work with characterized it in a way that I thought puts things in focus for me, that Terraform is a solution and CloudFormation is a tool, right? If you've got people sort of managing infrastructure, Terraform feels a little more natural, right? If you're building it into automation, CloudFormation feels a little more natural. So it just kind of depends on how you're using it. That's it. Any questions?
Slides?
That's the slides, yes. If anybody wants them.
When you claim that, and I think I'm with you on this, that CloudFormation has an advantage in an automated environment, do you think that's because of the shift in conversation where the state is?
I think that's a lot of it, yeah.
So if I were using another tool that had remote state or that determined its state at runtime, would you put that in that camp as well? Is that, would you use that state management as your main rubric there?
Well, actually, no, I don't think I would use the state management.
Okay.
I think it's the API.
Oh,
right.
Okay.
CloudFormation is an API. So I'm passing it that data structure. I'm getting that data structure back, right? I've got SDKs already written to help me make that call, right? I don't have those sorts of things with Terraform. What I would be doing is like capturing the text output of Terraform and doing like whatever regular expressions and stuff, trying to parse it, right? So it's not as friendly in my experience. There might be better ways to do it, but that's my experience. And we're running late. Any other questions?
When will you approve my Google Drive access that?
Oh, really?
Apparently so.
Request it and I'll approve it.
I already did.
All right, yes.
So how do you deal with secrets in general with Terraform? Both secrets Terraform needs to access things and secrets Terraform might create.
So you basically use a vault data provider, whatever that is, right? So the way we've done it, I would imagine I could also use like the AMS, AWS, KMS data provider, right? And you get access out, to get that secret, right? Or you can do what I did and pass it in as a variable, right? So I've got I stuck it in my bash RC file, right? whatever. But what you could do is do the same thing, pull it out of Vault or KMS, put it in an environment variable, pass it as an environment variable on the command line, right? All right. Further questions can be at the K-Town Tavern.
K-Town Tavern, where we are picking up his tab, because that's what
Woohoo!
you get. If you
I'm
choose
getting
senior
drunk
LOPSA,
tonight.
You have your tab picked up by LOPSA at the K-Town Tavern. Let's give a round of applause.